Swayam Prabha. Digital India. Educated India.
Hello, welcome to this fifth lecture of Module 10 on engineering geological facets of natural hazards and mitigation, landslide, earthquakes and induced seismicity. In previous lectures, we have elaborated about landslide and elementary aspects about natural earthquake as well as human-induced earthquake. Now in these lectures we will purely discuss about induced seismicity. In these lectures we are going to discuss about induced seismicity. Regarding this, we are going to introduce first what is induced seismicity, then definition of induced seismicity, about the classification of RIS, categorization of different type of levels or types of RIS, then mechanism of RIS and criteria. Friends, we have already discussed about earthquake and you all are well familiar about the impact of earthquake on our society. A lot of disasters and destructions we have observed, we have listened through TV and through newspaper. Beside natural earthquake, we have induced earthquake caused by different activities of human. The induced seismicity is generated due to injection of fluid inside the earth's surface, due to waste disposal, due to solution mining, due to extraction of groundwater, due to extraction of geothermal energy, petroleum, fuel oil, then extraction of metals in case of deep seated metal mining, and removal of large volume of rock strata and fluid extraction in form of petroleum, in form of different fluid materials. Then about the impoundment of water. If we are going to categorize different type of induced seismicity, then we can say that the induced seismicity is defined as the generation of seismic wave due to human activity. The induced seismicity can be categorized as intentional induced seismicity or non-intentional. The intentional seismicity, particularly induced seismicity, may be constructive in nature, may be destructive in nature. Non-destructive seismicity can be also categorized as constructive and destructive. Intentional seismicity, if we are going to see in way of constructive approach, then we are generally going to generate seismicity for development of seismic stratigraphy or delineation of subsurface utilized to develop sequence stratigraphy of an area useful for petroleum exploration and useful for sedimentological aspects uncover. So that the induced seismicity constructive in nature, seismic stratigraphic, then intentional constructive seismicity is a generation of seismic wave for subsurface exploration regarding different features available in petroleum reservoir or in other location. Intentional destructive, the bombing by the enemy's country to generate seismic shocks for damaging the nearby structure and damaging the nearby area. Similarly, non-intentional seismicity, which is destructive in nature, that is the drill and blast in mines. The intention behind the drill and blast to fragment rock. However, the vibration produced during blasting is going to affect nearby area in form of ground vibration and generating cracks, fractures, fissures in nearby houses. Constructive, the movement of vehicles, not intention to generate seismicity. However, the continuous vibration, effect of movement of different vehicles on road, is going to compact partially the material of subgrade lying below the road pavement. Sometimes the vibration produce intentional in construction of road to fill the voids available in aggregate or available in blasts. So, in addition to this intentional and non-intentional, one of the non-intentional seismicity which are debated in various communities throughout the world is a reservoir-induced seismicity. The reservoir-induced seismicity we are recalling in short as RIS. This RIS is due to impoundment of water behind dam. So here we are going to elaborate about generation of RIS. Before explaining the RIS, we are going to again see about the construction process involved in construction of dams and filling of water in reservoir. Suppose this is river channel in natural condition, and we are going to construct dam here as a barrier to impound water of this river behind this developed structure. For this, initially we are going to divert the channel with help of coffer dam or due to construction of some tunnels, so that the area nearby the dam side should be dry and clear, available for construction work. After completion of work, after construction of dam, then we are going to again restore the original path of river for filling of dam structure. Now we are going to start filling constructed dam in initial position at time T0. this bottom of the reservoir was fully dry in nature and without water. In natural condition, having some pores, some fractures, some cracks, some grouted zone, some strengthened zone, etc. When we are going to release some quantity of water to dam, then there is increment in load of water W sigma W1 at time T1. Then at time T2 sigma W2, time T3 sigma W3, likewise up to sigma Wn. Then this reservoir is up to complete level, having a maximum headwater level. Initially the strata at the time T0 was able to withstand with the lithospheric load caused by this overlying strata minimum and happy in survival condition. When we are going to release water with load sigma W1 or W1 simply, W2, W3, W4, then the strata lying below the reservoir is subjected to load summation of sigma W is equal to 1 to n. There is continuous increment in load with respect to time during filling. Due to this strata lying below the reservoir is subjected to additional load with respect to time. When the value of the sigma total is increased, then the strength of rock strata. In such condition, there is a generation of fractures on one side. On another side, the evolution of cracks and fracture is also supported by the enhanced saturation of some part of rock strata lying below the reservoir. Initially it was dry. When we started spreading water inside the reservoir, then some portion of the reservoir bottom is saturated with water, and as you know, the rock or rock strata saturated with water is going to lose its strength. Therefore, on one side there is increment in load, on another side weakening, similar to a sick person. On one side overloaded by the work, on another side the body is showing weak nature. In such situation, there is a development of number of discontinuities. Mechanically induced discontinuity becomes site for burst of energy, and the burst of energy moves in form of mechanical energy like P wave and S wave. In this way, the reservoir is going to influence nearby area and causing earthquake. There is no solid any theory with physical background to explain the concept. We are going to develop some theory based on evidences of RIS observed throughout world. We have number of example of reservoir induced seismicity, and reservoir induced seismicity has been reported from as many as 20 reservoir project previous data, but now we have data about the 187 reservoir projects of the world which have shown the RIS throughout the world of magnitude more than 4. However, the seismicity or earthquake caused by reservoirs having magnitude more than 5 is well experienced by the nearby area. RIS in 1960s about the magnitude of the 6 on Richter scale we have observed in Koyna area of India, and Zhenfinjiang of China area, Kariba in Zimbabwe, and Krembasta in Greece. Due to such RIS who have no connection with natural earthquake, but these areas have experienced earthquake of magnitude 6. Similarly, the RIS was associated with the initial impoundment of reservoir and some after proper completion of water impoundment or release. However, we have some exceptions of RIS which has been found to occur after some year of initial impoundment. Generally, we are having number of data concerned to RIS after 1 year, 2 year, 3 year, 5 year. However, in certain cases, in case of Kariba Dam, the RIS was produced after impoundment of water having gap of 8 years. Then in case of the Jingfengjiang project, after 13 years, the peoples of China were observed RIS due to this project. And in case of Aswan Dam in Egypt, the RIS was observed after 17 years, long gap. Based on such type of time dimension and others, we can conclude that RIS occurs generally magnitude ranging from 4 to below 7, and generally occurs during the impoundment of water or release of water, and then after release of water, after 1 year, 2 year, 3 year, 4 year we have minimum data, then 5 year. Exceptionally, we have observed some RIS as we have already discussed after 8 years, after 13 year and 17 year. Here some of the examples related to project located in India, Koyna Dam, having height 103 meter and started filling in 1962 and completed in 1967. Several RIS of magnitude 6.3 we have observed. In Zimbabwe, Kariba Dam, height is 128 and filling was in 1958 and 1963 6.2. So these dams have generated RIS of magnitude more than 6. However, in one of the project, Srinakarlina in Thailand has produced 5.9. Then the Greece Marathon have produced 5.7. Similarly, in USA, Oroville also. and some of the projects located in New Zealand, Australia, USA have produced 5 magnitude earthquake. If we are going to divide RIS in different category based on the release of water, change in level of water and others, then we can say that the RIS can be divided in 3 categories. One is instantaneous RIS, delayed RIS, and protected RIS. As the name indicates, instantaneous RIS we can observe at initial time of water release, the loading from water and increase in pore pressure responsible for such initial or instantaneous RIS. However, certain RIS we have observed after filling of reservoir recognized as delayed RIS, and this delay RIS is accelerated due to diffusion of pore pressure after considerable time gap. Then protected RIS, after fully completion of reservoir and the dam has started functioning properly, then time to time there is a fluctuation in level of reservoir due to heavy rain or due to storms and others, that also going to cause RIS in nearby area. Initial seismicity, if we are going to see in view of Mohr's-Coulomb's criteria, in this horizontal stress distribution and vertical stress distribution as sigma 1 and sigma 3 due to lithostrata, you can see originally this zone indicates there is no failure when there was no water. Then when we are going to add water, then there is a development of 2 things. One is there is a difference in values of the delta sigma normal, and also there is increment due to development of pore pressure due to saturation, which we have already discussed in our initial discussion, and responsible for development of failure envelope, means development of fracture, which becomes site for burst of energy and propagation of mechanical waves like P wave, S wave, and induced wave, R wave and L wave. In case of delayed seismicity, there is a diffusion of pore pressure after considerable gap of time, and that also responsible for generation of seismic shocks due to burst of energy. Here case wise, if we are going to see about filling of dam, here this figure A is showing the phenomena regarding the filling of reservoir with help of the plot about the lake level L and with respect to time. This zone indicates there was no water, then after considerable time there is increase in water level with increase in time, and after considerable time T2 this reservoir has reached original level as per specification of dam authority. When there is increment in water quantity, then due to increment in water quantity, there is increment in normal load, which was experienced by the bottom of reservoir. Then after this zone, then the load is at constant level and survive for considerable time, forever. Beside this, here you can see, initially there was no development of pore pressure. When there is increment, then there is a development of undrained condition and increment in pore pressure, that going to reduce the effective load of water induced normal stress and then stabilize with respect to this. During the maximum reach of the normal stress and the subtraction caused by this pore pressure, there is a chances of failure of strata as marked by this zone. Then after considerable time, then there is again failure of strata, although the normal load caused by increment of water or water level is constant, but there is still development of failure of strata becomes site for generation of RIS due to diffusion of pore pressure. Here we are getting time delta t. Delta t is a gap. This gap is indicating about delay. So this zone is indicating about instantaneous RIS, and however this zone is indicating about delayed RIS. You can see one case of dam site, Monticello Reservoir seismicity. You can see at this zone there is a development of more frequency of RIS in this zone due to initial filling of reservoir of Monticello. Then after considerable gap, there is again higher frequency of RIS due to diffusion. So this way we are going to explain about instantaneous RIS and delayed RIS. Beside this, what happens in case of dam? The water present in dam at constant level, there is no problem. We can receive instantaneous RIS, delayed RIS. However, sometimes what happens, the dam level starts fluctuating, sometimes up and then again original position, then again up, then original position. For example, during heavy rain, there is increase in water level. It means there is increase in enhanced load to the bottom of the reservoir. In such situation, the reservoir is under cyclic stressing. And friends, as you know, the rock strata under cyclic stressing is going to lose almost 30 to 40% strength, and only 60 to 70% strength is remaining present under cyclic loading in comparison to the normal stressing. So in such situations, there is further development of fractures that going to produce mechanical wave due to burst of energy, and this change in scenario due to fluctuation in level is also responsible for generation of RIS on one hand. That generally occurs in case of week. Generally rainfall may be continuous for 1 week, then there may be some gap. It is a general trend. However, in certain cases, This type of rainfall event due to normal raining is generally extended a period some day to maximum week. However, in certain situations, when the height of increment in water is far more than the normal level. In previous condition, the fluctuation is less than original level or original depth of water, which are able to produce RIS in period of day and week. However, in case of this, when this H fluctuation is more than normal in form of storm. In storm condition, the fluctuation levels, the water increment is more, but in water level is normal. In such situation, there is a formation of fissures and cracks of bigger dimension going to create burst of energy, huge quantity of energy and high magnitude RIS. In such situation, such type of events generally occur in tunes of year. Sometimes it occurs, not always. Therefore, in news or in general convention, you have observed in TV and others, when there is any storm or destructive major event, then there is also earthquake, erosion, landslides and others. That all phenomena is connected to each others and creating natural havocs for life and property of humans. Seismicity at Monticello we have already discussed in brief. The Indian example, we have Koyna earthquake, famous worldwide, and lot of studies we have done on Koyna earthquake. One of the parameters that responsible for generation of seismic waves, that is hydraulic conductivity, and hydraulic conductivity we can easily calculate with this formula K capital is equal to small k gr by m, where K is a permeability, G is acceleration due to gravity, where R and m are the density and dynamic viscosity of water respectively. Regarding this, under certain specific conditions, we are found the induced seismicity is highest when K range 10 to power 9 to 10 to power 7 meter per second. Hydraulic diffusivity value of fracture associated with seismicity to lie between 0.1 to 10 meter square per second, and the permeability which are showing the generation of seismic waves is ranging 5 into 10 to power 16 minus 16 to 5 into 10 to power minus 14 meter per square. That is called as seismic permeability. Besides this, we have certain tips regarding the RIS. The RIS generally occurs in dam having height more than 100 meter. Then dam located nearby normal fault, non-thrust fault. Therefore, the Himalayan region is showing lack of RIS. People unnecessarily feeling fear regarding the construction of dam in Himalayan region, because Himalayan region is dominated by thrust, and thrusted area cannot produce RIS. These materials I have prepared from the paper written by Pradeep Talwani in 1997 on the nature of reservoir-induced seismicity, published in Pure Applied Geophysics, volume 150 and PPT, page number 473 to 492, and partial supports from this book. Friends, as you know, the induced seismicity is caused by human activity besides natural earthquake, and the induced seismicity can be divided on the basis of intention and impact as intentional and non-intentional, constructive and destructive seismicity. The reservoir-induced seismicity is the major aspect concerned to induced seismicity, having instantaneous, delayed and protected RIS. It depends on the nature of geoground, types of dam and level of water in. Dear friends, in this class we have elaborated about induced seismicity, which is different from the natural earthquake. Thank you very much for your